You stay in there with them.
All right, here we go. Welcome to Friday. Go ahead and get out your homework. Let's go over it. Any questions on the homework?
Number 20.
Let's take a look at number 20, 206. All right, number 20, it's that one that I kind of, I'll see if I can draw a picture for you.
Well, so remember sending out
All right, please put your everything on mute, please. All right, number 20 looks like this. You have a triangle, and this ends up being an equilateral triangle. And you're told that this is X, and Y is right here. And you're asked to find what X and Y is. Well, step number one, equilateral triangle. All sides are the same and all angles are the same. So immediately, I know this one right here, and all three angles on the equilateral triangle are 60 degrees. Notice that Y and 60 degrees are vertical, so therefore Y has to be equal to 60 degrees. So how about X? X is a bit more challenging. Well, let's see. Well, immediately I know that, oh, I drew my triangle slightly wrong. We're told that there's a tick mark right here as well, too. All right. Well, we know that this angle right next to it is 120, right? Because it makes a linear pair. And then, so the question is, where does the other one go? Well, the issue is that, and I drew it slightly, it's actually a bit more like this, right? So ignore that part. So X is right here. So if this is congruent to this, then this is also a isosceles triangle. So I'll draw that portion a little bit better. So this would be what we're looking at here on the right. So we know that this is 120. We don't know what X is right now, but we do know it's an isosceles triangle. So this is 120. There's 60 degrees left, and therefore this angle is congruent to this angle. So 60 divided by 2 is 30. So we get X is equal to 30. Sorry for the horrible drawing, and I'm doing this with a mouse. So that's why it looks so bad. Okay, so that's the answer to that one. Anyone else? All right, I will call off the answers. Here we go. Number 1 is 67 degrees. Number 2 is 13 degrees. Number 3, there's 2 answers on number 3, 112 degrees and 34 degrees. Number 4 is 33 degrees. Number 5 is 62 degrees and 62 degrees. Number 6 is 31 and 31 degrees. 7 through 10, I need to look at your pictures. Make sure you take clear, legible pictures. So picking up at 15, X is 65 and Y is 25. 16, X is 20 and Y is 130. Number 17, X is 72 and Y is 36. Number 18, X is 35, Y is 130. Number 19, X is 84, Y is 126. And the last one we just did, X was 30 and Y is 60. And that was it. All right, make sure you attach that if you haven't already to your homework or to your assignment page. We are going on. I started grading your quizzes. I don't have them all graded. Some of you don't have them all turned in as well. Make sure you turn them in. By Sunday, that will turn into a 0. Here's your homework for tonight. Notice 2 parts, class exercises and written exercises, 2 parts. 1 through 7 on the class exercises and 1 through 16 on the written exercises. You will absolutely positively need to draw pictures today. You got to draw pictures in your notes. All right, remember this information is also on the assignments on Teams. Special quadrilaterals, why are they special? So they're quadrilaterals. We always like to use the word special. All right, so today it's going to seem like you're drinking from the fire hose because there's a lot of information. Here we go. Number one, we've already written this one down. Don't write this definition down. I will remind you that a polygon is closed, meaning that you can't get to the inside without crossing a line. Plane, meaning it's a flat surface, or you can draw it on a flat surface. And a figure means shape. So it's a closed plane figure made up of segments that are joined at their end points. Yesterday we saw our first polygon called a triangle. But remember, the segments must be joined at their endpoints. There are 3 segments right there, but they're not joined at their endpoints. That's why we don't recognize it. However, if we do join them at their endpoints, we get to a recognizable shape. Our first polygon was a triangle yesterday. We get to our second one today. In the bottom there, write this down, quadrilateral. A quadrilateral, quad meaning 4, lateral meaning sides. Well, literally by the definition or the a translation of those words, it's a 4-sided polygon. A quadrilateral is a 4-sided polygon. And boy, are there a lot of them. Just like there are a lot of names for triangles, there's a lot of names for quadrilaterals. That's what today's class is on. Understanding the names and understanding what's so special about these quadrilaterals. So this is going to be your largest thing that you write down today. We're going to classify our quadrilaterals. At the top, I just want you to draw a shape that has 4 sides and label it quadrilateral. A quadrilateral, nothing special about it. We can't say anything other than it has 4 sides. Next shape, I want you to draw an arrow pointing towards that shape. And then I want to literally, you got to draw this exact shape. This is called a trapezoid. A trapezoid has 1 pair of parallel sides. That means 2 sides are parallel, the other sides are not. That is your classic shape of a trapezoid, where you have 1 set or 1 pair of parallel sides. All trapezoids are quadrilaterals. That's why the arrow points to quadrilateral. Not all quadrilaterals are trapezoids. That's why there's not an arrow going from quadrilateral to trapezoid. The arrow goes from trapezoids to quadrilateral. Next one, draw me an arrow pointing towards quadrilateral, like I did right there, and draw that shape. That shape is called a parallelogram. A parallelogram, unlike a trapezoid, both pairs of opposite sides are parallel. Notice on a trapezoid, only 1 pair. But on a parallelogram, both sets of opposite sides are parallel. That's why it's called a parallelogram. Notice which way the arrow points. It points to quadrilateral. All parallelograms are quadrilaterals, but the arrow doesn't go in the other direction. So not all quadrilaterals are parallelograms. Remember, this class will be posted, so if I end up going too fast on this particular slide, you can always watch the video. All right, next arrow points to parallelogram. And it's this shape. We're all familiar with it. It's a rectangle. The definition of a rectangle is a quadrilateral or a parallelogram that has 4 90-degree angles. Notice the arrow points to parallelogram. All rectangles are parallelograms. All rectangles, therefore, are also quadrilaterals. Not all parallelograms are rectangles, though. Not all quadrilaterals are rectangles. No trapezoids are rectangles. You can kind of figure out where we're going from here. Have an arrow pointing to the rectangle. Anyone want to take a guess what the shape is?
Square.
Squares. A square has 4 90-degree angles and 4 congruent sides. So a square is a rectangle with 4 congruent sides. Notice the line is pointing to rectangle. So all squares are rectangles, right? Not all rectangles are squares. No trapezoids are squares. Some parallelograms are squares, but not all parallelograms are squares. A square is a parallelogram. A square is a rectangle. A square is a quadrilateral. A square is not a trapezoid, though. All you got to do is follow the arrows, and it tells you. We have one weird one, and it gets two sets of arrows. We're going to have an arrow pointing to parallelogram, and we're going to have an arrow pointing from square. And it's called a rhombus. Not called a diamond, it's called a rhombus. A rhombus is a quadrilateral with 4 congruent sides. A rhombus is a parallelogram. Squares are also a rhombus because a square has 4 congruent sides. But only some rhombi is plural. Only some rhombi are squares. All rhombi are parallelograms. Some rectangles are rhombi, but not all rhombi are rectangles. All of these shapes are quadrilaterals. All of them are quadrilaterals. This is the slide that will answer half of the homework questions. By the way, this particular slide is not in the book. I just find it useful for kids. Okay, like I said, I will post this later on today before 4 p.m. So if you need to refer back to this particular slide, you got to pull it up from the class. But we're going to move on. All right, how do you name quadrilaterals? Well, we name triangles by their corners. We name quadrilaterals from their corners or their vertices, right? And we pick one. It doesn't matter which one you pick, and we either go clockwise or counterclockwise. So this would be quadrilateral A, B, C, D. Or if I don't start with A and I start with D, it could be D, A, B, C. Or if I go counterclockwise, D, C, B, A. There are lots and lots and lots and lots of ways to name this one quadrilateral. But you simply need to pick a letter and either go clockwise or counterclockwise. Don't skip a letter. So tonight for homework, they're going to talk about quadrilateral, A, D, C, B or something like that. All right. Now we're going to talk about each one individually, the parallelogram, the square, the rectangle, the rhombus, the trapezoid, and we'll talk about some special characteristics about each. So we'll start with the parallelogram. Obviously, a parallelogram, by definition, opposite sides are parallel. So what does that mean? That means that side AB, that one right there in red, is parallel to the opposite side, DC. Remember, parallel symbol are these two train track looking symbols right here. Okay. Well, it says both sets of opposite sides are parallel, so therefore AD must be parallel in blue to BC. Okay, so that's by definition of what a parallelogram is, but we get more because of this construction. So we get what are called consequences because opposite sides are parallel. So here's what you need to write down. If opposite sides are parallel, then opposite sides are congruent. So that means that AB is the same distance as DC. It also means that opposite angles are congruent. All right, this one's a bit more challenging. So opposite, what does that mean? That means that A is opposite to C, and that angle D is opposite to B. So those two consequences, make sure they're in your notes. So that means that AB is opposite to DC, therefore that means that AB is congruent to CD. Or DC. It also means their measurements are equal, so we could put tick marks. But we have two sets of parallel sides, so that means the other sides are also parallel and congruent. That means their measurements are equal. So AD is congruent to BC, therefore they are. Notice I put 2 tick marks there, well, because we don't know if their distances are the same as AB. That second consequence there, that opposite angles are congruent. That means that angle A is congruent to angle C. Now, you haven't seen this measurement before. These are called arcs. This little archy looking thing right here, that means that's the congruency symbol for a diagram for only angles. Side measurements get tick marks. Angle measurements, if they're congruent, get arcs. So A is congruent to C, and D, I got to put 2 arcs because it's a different angle. D is congruent to angle B. Boy, that's a messy, messy, messy diagram now. But those are the 2 consequences. There's more we'll talk about in high school. But those are the 2 consequences for 8th grade geometry, is that opposite sides are congruent and that opposite angles are congruent as well too. That's a lot to talk about. But that's what you have to have for parallelograms. If the drawing the picture helps draw the picture, if not, what's in yellow here, those are the consequences. Opposite sides and opposite angles are congruent. Anyone lost or needs a better explanation? Okay. So how do we use this? Well, they'll give you a parallelogram. They will say it's a parallelogram. They will give you one side. For instance, AB is 6, and they will simply ask you, how long is DC? Well, our consequences says that opposite sides are congruent. Therefore, if AB is 6 centimeters, then DC must also be 6 centimeters. Notice when we talk about distance, we lose the tilde, we lose the segment symbol over the top. Remember, when there's no segment symbol over the top, they're asking for a actual number, a distance. Okay. This also works for angle measurements. We know that if it's a parallelogram, that opposite angles are congruent. So we find out what we're given. We're given that angle A is 100. Therefore, the opposite of A is C. So therefore, C is also 100 degrees. Once again, if we're talking about angle measurements, we put an M in front of it. We lose the congruency symbol. We put an equal sign. So therefore, the measure of angle C is equal to 100. All right, that's not too bad for those two things. Parallelograms are pretty easy. Questions? Okay, it does seem simple. They will make it more complicated. We will use all the information that we know. Notice what this says. Given parallelogram ABCD, find the unknown values. So let's see, I got to find the measure of angle BCD, find the measure of angle 1, and find the measure of angle D. All right, one at a time. Measure of angle BCD. So sometimes what will help you to do is to simply draw. So let's see. BCD would be this angle right here. See what I did there? So let's see. This angle right here is opposite that angle. Okay, that one's a pretty easy one to do. So if angle A is 110, then angle BCD would also be 110. All right, so that's the easy one. The measure of angle 1. Well, I guess we could label this one as being 110. Oh, look. Anybody want to tell me what we got here now?
A supplementary line.
We do. We have a line, and we know that the two angles added together are 180. Therefore, angle 1 would be?
70 degrees.
And how did he get that so easy? I don't know who said that. Who said that?
Jace.
Jace. So how did he know that? They're supplementary. That means the two angles added together are 180 because they make a line. Therefore, 7 degrees. Okay, 2 out of 3. Where is angle D? Angle D is right here. It's the hardest one. There's nothing. If we knew what angle B was, we could find angle D. So the question is, how in the world are we going to get that? Anyone hints? Ideas? This is the hardest one. Here's your hint. It's a parallelogram. So this side is parallel to this side. Further, those two parallel sides are cut by this transversal. What do we know about this angle and this angle? Two parallel lines cut by transversal. What can you tell me about corresponding angles?
They're the same.
They are the same. So angle 1 would correspond with ADC, or in other words, angle D, right? Therefore, they correspond, therefore they are equal, and therefore, since 1 was 70, then that one's. So they are absolutely, some of these going to be challenging, right? You may get the first one, you may get the second one, you may get stuck on one of them, but that one, that's how that one was done. Questions? Okay. Next shape, trapezoid. Trapezoid. Remember the one set of parallel sides. So AB is parallel to DC or CD. Okay. AB is parallel to DC or CD. Consequences. All right, trapezoids come in 3 flavors. 3 flavors. We'll talk about that before we talk about consequences. The first flavor, well, this is just a plain Jane trapezoid, nothing special about it. It's kind of just regular looking, right? Only thing you can say is that AB is parallel to CD. The second one is going to be called an isosceles trapezoid. Well, an isosceles triangle has two congruent sides. Guess what you're going to be able to say about an isosceles trapezoid?
Yes. Same thing.
Same
All right,
thing.
I'm gonna start signing this one.
So we're going to call these two sides that are congruent the legs. So these are the legs of the trapezoid. The two parallel sides are called the bases. So an isosceles trapezoid, you have two congruent sides, and they will always be marked with the tick marks. So the consequences of an isosceles trapezoid is that AD is congruent to BC. Because it's and it will be marked, right? It's not going to just say you have an isosceles trapezoid without it being marked. Now, it could be marked with distances instead of tick marks, but it will certainly be marked. So I said 3 flavors. The last flavor, there are consequences to an isosceles trapezoid. The other consequence is that the two angles that are next to each, I didn't say adjacent, that form the relationship between the base and the leg, those two angles are congruent. A and B are congruent, and the bottom two, D and C, are congruent. So this is the first one we have consequences other than two parallel lines. All right, the two consequences are that the legs are congruent, and they're called base angles. The base angles are congruent as well too. Now be careful, make sure you write down exactly what it says here. A and B are the ones that are congruent. They're not the same as D and C, right? But D and C are also congruent. Notice D and C are acute, and A and B are obtuse. So A is congruent to B, and D is congruent to C. This is only for isosceles trapezoids. Last flavor and its consequences is called a right trapezoid. So guess what a right trapezoid has?
3.
A right side.
It's got a right, not a side, it has a right
Angle.
angle. All right, so this is a right trapezoid. A right trapezoid has, well, it turns out it actually has 2 right angles. Angle D will be right, and they only label one of them, and also angle A would be a right angle. So not only is AB parallel to CD, but the measure angle D is equal to 90, and the measurement of angle A is equal to 90. Both of these will be 90 degrees. They only choose to label one. Remember I said today is like drinking from a fire hose. Lots and lots and lots of information. Once again, if you missed something, wait until I post the video of the class, rewatch the video for the part that you missed. We okay? All right, moving on. Last shape of the day is a rhombus. All right, so, well, the consequences of a rhombus, well, by definition, all the sides are equal. So we can put one tick mark around all 4 sides. We also, because it's a parallelogram, we get that opposite angles are congruent as well too. So we get opposite angles are congruent. So all 4 sides are congruent, and the opposite angles are congruent. And why we get that is because it's a parallelogram. Remember, parallelogram, opposite sides are congruent and opposite angles. A rhombus is a parallelogram, so, well, all 4 sides are equal, that's by definition. But then again, since it's a parallel, opposite angles are congruent. This is a lot of information, lots of information. We okay? All right. That's going to do it for today. What I'd like you to do, just briefly, grab your books. Let's just look over the problems really quickly and see if I can answer any quick questions. So remember, 2 parts: class exercises 1 through 7, and then written exercises. For the class exercises, they are asking you to look at the shape and then name it. So it's not too complicated right there. But they want all the names of it. I'm going to do one of them for you. Now it gives you all the possible names: quadrilateral, square, rectangle, trapezoid, parallelogram, isosceles trapezoid, and rhombus. So look at question number 7 on written exercises. Clearly that shape is a quadrilateral. It has 4 sides. It certainly appears to be a parallelogram because the opposite sides are parallel, and it looks like all the sides are the same. Therefore, it is also a rhombus. So the answer to number 7 on class exercises is quadrilateral, parallelogram, and rhombus. Rhombus is the most descriptive. Quadrilateral is the least descriptive one of those. But they want you to put all possible names. All right, looking at the written exercises 1 through 16. All right, if you notice questions 1 through 6, it's just the same one that I did in class, except flipped around and different numbers. So that one's pretty simple. So 7 through 10 might be the only ones that give you issue. You're told that it's an isosceles trapezoid. Remember, isosceles trapezoids AB and DC will be congruent. You can use that to help you answer. It also says that ABCD or ABCE is a parallelogram. Remember, for parallelogram, opposite sides and opposite angles are congruent. Lastly, 11 through 16, these are simply true and false. The answer to these will be from that first diagram that we did. Remember, we drew the diagram that had all the arrows. Let me see if I can flip to it real quickly. We'll take a look at that and see if we can answer one. So here is that picture that we drew. And let's see if we can answer question 15. A parallelogram with at least one right angle must be a rectangle. So if you are a parallelogram and you have one right angle, you must be a rectangle. This one says 4, so initially you want to say no, but if 1 is right, well, remember, 2 parallel lines cut by a transversal, the opposite side would be, alternate interior angles would be congruent, so that one's going to be 90, or you could say corresponding, that one's going to be 90. So yeah, just one right angle would make all 4 if it's a parallelogram. So if this is 90, then that's 90, that's 90, and that's 90. So 15 is actually true. A parallelogram with one right angle. Just think about if you put one right angle right here, you'd have to move this side over to make it 90 degrees, and that would pull all the other angles and make 90 degrees. So I will say 11 through 16 are the more challenging ones, the true-false ones. And I am out of time for today. Any specific questions? No? Okay, so you guys have a good weekend. Also remember, a few of you have not taken your quiz from yesterday. I will put zeros in the grade book by Sunday if I don't have that quiz turned in. So make sure you turn in your quiz. Most of you did very fine on the quiz as well. Make sure you turn in that quiz. Make sure you do your homework, and make sure all your pictures are legible so that I can grade them. And since there are no questions, I will end right here, and you guys have a good weekend. See you.